All right, for example 1, we're going to be talking about some students' measurements of a TV screen. When we measure a TV screen, we measure diagonally across the TV and we go corner to corner. So like for this TV, we would line up our measurements similar to this, but it's really hard to get an accurate measurement sometimes, even when we're measuring. So what we're looking at today is finding the percent of error that we have when we measure. So for this problem, we're going to say some students have measured our TV screen, and we're going to give some measurements for them. So you need to copy this table down on your notes, and then we're going to fill in their measurements. So we're going to say Taylor measures 2 times, and the first time Taylor measures 15 2/8 of an inch. And then the second time Taylor measures 15 3/8 of an inch. The first time Connor measures, Connor gets 15 4/8. And the second time, 14 7/8 of an inch. Finally, Jordan measures and gets 15 4/8, and then 14 6/8. So for our problems, we're going to find the absolute error for the following problems and explain what this absolute error means in context. So for this one, we're just talking about the difference between what the actual measurement was and the measurement that the students got. So for this problem, we're going to say that this TV screen was 15 inches. And so we're going to find the difference between these two. In order to do that, we're going to use absolute value. That way all of our measurements are positive and we don't need to worry about which we do first. I always like to start with the measurement that I measured and then take that and subtract out what the actual measurement was. So we're going to do Taylor's first measurement, which was 15 2/8. And we're going to subtract out the actual measurement, and we're going to put that in our absolute value brackets. Now, if you remember from numeric analysis, your absolute value brackets mean the distance from 0. So this value will always be positive. When we subtract this, we are left with an absolute value of 2/8, which when we simplify and pull it out of the absolute value would be 1/4 of an inch. So Taylor's measurement 1 had an absolute error of 1/4 of an inch. Let's look at Connor's measurement 1. So if we go back to our table, Connor's measurement 1 was 15 4/8. So we're going to go 15 4/8 minus the actual measurement. We're going to take the absolute value of that. So we get the absolute value of 4/8. When we simplify and pull this out, we get an absolute error of 1/2 inch. Our next question is we're going to look at Jordan's measurement 2. So if we look at Jordan and Jordan's measurement 2, Jordan had a measurement of 14 6/8. So 14 6/8, and we're going to subtract out the actual measurement in absolute value brackets. When we subtract, we get an absolute value of -2/8. So when we pull this out and simplify, we get an absolute error of 1/4 of an inch. Now let's think about this absolute error. Do we think that our absolute error should be a large number or a small number? Well, if we think about the distance from 0 and what our actual measurement is, we want that absolute error to be very small. We want it to be as close to the measurement as we can actually get. So we're going to say that our absolute error, BSO, helps if I can spell right, huh? L-U-T-E, there we go. Absolute error should be a smaller number. This means we would be close to the actual measurement. We would be close to the actual measurement. So our last question says, can you derive a formula or rule to calculate the percent that our absolute error is of the exact value? So that means our exact value is our whole, and we're looking in the absolute error would be our part, and we are wanting to find the percent. So we're going to define a couple of variables. Let me get a different color here. We're going to say that our x is the exact value. And you can pick any number or a letter. I'm going to pick A for the measurement. Now, I like to take the measurement and subtract out the exact value, like what we did on our examples. And then we find the absolute value of that. Now, if we want to find that percent, we need to divide it by the absolute value of the exact value, because we want it of the exact value. So we're going to divide our part by that whole. And then we're going to times it by 100% to get our final answer.